Hi all, welcome back to the 5-Minute Tech channel. Today we'll be talking about Grpc, which is a high-performance open-source universal RPC framework designed by Google. Grpc is a lightweight and quick system for requesting data. It's a fresh take on the old method which was called as RPC. It is lightweight and requires very little resources, which makes it a handy solution for extremely low-powered situations. Also, it is efficient. It uses protobufs, which we'll be talking about in detail in some time, which is a method of serializing structured data, which focuses on serializing communication. It is open source and can be freely used, modified, or forked. What are the benefits of Grpc? It is modern, high performance, lightweight RPC framework. Contract first API development is present in this, which we do by using protocol buffers by default. It allows for language agnostic implementations. Tooling is available for many languages to generate strongly typed server and clients, and we're talking about .NET tooling. Supports client, server, and bidirectional streaming calls and reduces network usage with protobuf binary serialization. Grpc uses a contract first approach in API development. Services and messages are defined in .proto files. So we'll be talking in detail about how the .proto file helps in the communication. .NET types for services, clients, and messages are automatically generated by including the proto file in the project. So Grpc is of two parts. One is service and the client, like any communication. In the service we have a proto file. Protocol buffers, protobufs as it is called, are used as an interface definition language by default. The .proto file contains the definition of Grpc service and the message that is sent between the clients and servers. Grpc clients are basically concrete client types that are generated again from the same proto files which are present in the client project. The concrete Grpc client has methods that translate to a Grpc service in a proto file. A Grpc client is created from a channel. A channel represents a long-lived connection to a Grpc service. Now, when this channel is created, it's configured with options related to calling a service. So the Grpc can be represented by this simple diagram, wherein we have the client and service. The client is having a Grpc stub which communicates bidirectionally with Grpc service through over HTTP2 protocol, and it uses a proto file for doing that communication. So we'll be quickly switching over to the demo of this application using Grpc. So this example is taken from Microsoft Docs, and that could be referred for more details. So on the left hand side we have a Grpc service. Now Grpc service has a one service class, and it has a proto file and the basic middleware configured here. The proto file is having the syntax, what kind of proto it is. It also has the namespace which it belongs, the package, and also it has the different methods. For example, it is having a request message containing user's name, so it is defined the name as 1, and the response message contains the greeting, so that message will be present in hello reply. The Grpc service has these implementations. It has for example a method called say hello. Now for representation purpose I have written a console write line to show you guys how communication works, and also we have the actual for example, there could be an API, there could be a response that could be sent over the wire, and that could be coming from here. Similarly, for the client we have a proto file. It's almost the same, except the namespace different, which can be observed here. So if you see here, the namespace of these two are different. One is client and one is server, whereas the other details remain the same. The other parts are pretty simple. In the program CS we are calling a particular Grpc channel, which we talked about in the slide, and that Grpc channel belongs to 5001, which happens when we run this Grpc service. So I'll be showing that right now. So when I run this Grpc service, it will be listening on 5001, as you can see on the screen. Now what the client does, it tries to get the information, tries to connect to the service, and that's what will happen when you run the Grpc client. So running the Grpc client, You could see if we, as soon as we ran the grpc client, we get 2-3 informations. As soon as the client is launched, we get a message on the service which says name greeter client, and that comes from the part wherein we have mentioned name and the request.name. So this is what it comes back here along with the other information. So this is how the grpc client and service interact with each other. So that will be all for the grpc topic. Thanks for watching the video. If you like the video, do press like and subscribe to the channel, and you have a fantastic day.